Good morning, students. Welcome to the class. This class is the continuation of the previous class. The first concept in this class is polar form. Polar form or mod amplitude form. Mod amplitude form of the complex number z. See, let z is equals to a plus ib. Put a is equals to r cos theta and b is equals to r sin theta. Therefore, mod z is equals to r and theta is equals to principal argument of z. Principal argument of z. Then z is equals to r into cos theta plus I sin theta is called mod amplitude form. Mod amplitude form of z or polar form. Polar form of z. Here theta is equals to tan inverse b by a. Tan inverse b by a. Note. Cos theta plus I sin theta is abbreviated as cis of theta. You see here cis of theta 1 into cis of theta 2 is equals to cis of theta 1 plus theta 2. Next, cis of theta 1 by cis of theta 2 is equals to cis of theta 1 minus theta 2. General mod amplitude form of z. This is defined as z is equals to r into cis of 2k pi plus theta for k belongs to I. Theta is the principal argument of z. Here we have some properties. First property, argument of z to the power of n is equals to n into argument of z plus 2k pi for some k is equals to 0, -1, 1. Second one, argument of z1 by z2 is equals to theta. This implies argument of z2 by z1 is equals to 2k pi minus theta for k belongs to I. For k belongs to I. If third one, if z1 is equals to r1 cis theta 1, z2 is equals to r2 cis theta 2, where mod z1 is equals to r1, mod z2 is equals to r2. Theta 1 is argument of z1. Theta 2 is equals to argument of z2. Then mod z1 plus z2 square is equals to mod z1 square plus mod z2 square plus 2 mod z1 mod z2 cos theta of theta 1 minus theta 2. Suppose here it is minus, then here it is minus. So this is equals to r1 square plus r2 square plus or minus 2r1 r2 cos of theta 1 minus theta 2. Next, mod z1 plus z2 whole square plus mod z1 minus z2 whole square is equals to 2 into mod z1 square plus mod z2 square, which is equals to 2 into r1 square plus r2 square. Similarly, mod z1 plus z2 whole square minus mod z1 minus z2 whole square is equals to 2 mod z1, 4 mod z1 z2 into cos of theta 1 minus theta 2, which is equals to 4 r1 r2 cos of theta 1 minus theta 2. Next, Euler form. Euler form of z. Let z is equals to r into cos theta plus I sin theta. This is equals to r into e to the power of I theta, where r is equals to mod z and e to the power of I theta is equals to cos theta plus I sin theta. This is called Euler form. Euler form. Note, e to the power of I theta is equals to cos theta plus I sin theta. If you put theta is equals to minus theta, this implies e to the power of minus I theta, which is equals to cos theta minus I sin theta. This is first point. Second point, modulus of e to the power of I theta is equal to mod cos theta plus I sin theta, which is equal to square root of cos square theta plus sin square theta, which is equals to 1. Next, third one, e to the power of I theta is equals to cos theta plus I sin theta. E to the power of minus I theta is equals to cos theta minus I sin theta. So, adding these two equations, e to the power of I theta plus e to the power of minus I theta, which is equals to 2 cos theta. This implies cos theta is equals to e to the power of I theta plus e to the power of minus I theta by 2. This is in hyperbolic functions cos h of I theta. Cos h of I theta. Suppose subtracting 1 minus 2. 1 minus 2. This implies e to the power of I theta minus e to the power of minus I theta, which is equals to 2I sin theta. 2I sin theta. This implies I sin theta is equals to e to the power of I theta minus e to the power of minus I theta by 2. This is in hyperbolic function sin h of I theta. Therefore, I sin theta is equals to sin h of I theta. So in the same way, we develop the formulas sin I theta, cos I theta, tan I theta. Similarly, for hyperbolic functions in terms of the imaginary units. Sin of I theta is equals to I sin h theta. So cos of I theta is equals to cos h theta. Tan of I theta. is equals to I tan h theta. I tan h theta. Cot of I theta, which is equals to minus I cot h theta. Sec of I theta, which is equals to sec h theta. Sec h theta. Cosec I theta, which is equals to minus I cosec h theta. So these are the relations between the hyperbolic functions and the trigonometric functions. Now we see the inverse trigonometric with the inverse hyperbolic functions. Sin h inverse theta, sin h inverse theta, which is equals to minus I sin inverse of I theta. Cos h inverse theta is equals to minus I cos inverse theta. Tan h inverse theta is equals to minus I tan inverse I theta. So these are the relations between hyperbolic and the trigonometric ratios, inverse trigonometric ratios. Next, let z is equals to r into e to the power of I theta. Log z, then log z, this implies log z is equals to log of r into e to the power of I theta. This is equals to log r plus I theta. This is equals to log of square root of a square plus b square plus I into tan inverse b by a. Based on these concepts, now we solve some problems. First problem. If mod z minus 1 is less than or equal to 3, then find the maximum value of mod z plus 4. Mod z plus 4. Consider mod z plus 4. Express this mod z plus 4 in terms of z minus 1. So this is z minus 1 plus 5. So this is greater than or equal, is less than or equal to mod z minus 1 plus 5. So which is less than or equal to, mod z minus 1 is less than or equal to 3. So 3 plus 5, which is equals to 8. Therefore, mod z plus 4 is less than or equal to 8. Therefore, the maximum of mod z plus 4 is equal to 8. Second problem. If mod z1 minus 1 is less than 1, mod z2 minus 2 is less than 2, and mod z3 minus 3 is less than 3, then find mod z1 plus z2 plus z3. Solution. Given that mod z1 minus 1 is less than 1, this implies 0 less than mod z1 is less than 2. Minus 1 comes to this side. Mod z2 minus 2 is less than 2. This implies 0 less than mod z2 is less than 4. Mod z3 minus 3 is less than 3. This implies 0 less than mod z3 is less than 6. Consider mod z1 plus z2 plus z3, which is less than or equal to mod z1 plus mod z2 plus mod z3. So less than or equal to 2 plus 4 plus 6, which is equals to 12. Next problem. If Z belongs to a set of complex numbers, then find the minimum value of mod z minus 1 plus mod z minus 5. Mod z minus 1 plus mod z minus 5. Solution. See, since mod z1 minus z2 is always less than or equal to mod z1 plus mod z2.